We're going to go through 4 different examples of graphing quadratic functions that are all expressed in vertex form, as well as being able to find some various characteristics of these graphs, including the axis of symmetry and vertex and intercepts. So with this very first equation, it is expressed in vertex form. So I'm going to write this, though, just a little bit differently. So you're going to see that we have this quantity of x minus 3 squared. Now, there isn't really anything added or subtracted on the outside, but I'm just going to put a plus 0. So what I told you just previously is that this number right here corresponds to the number of units of horizontal translation, and this right here does correspond to the number of units of vertical translation. So the h value right here is actually a 3, and the k value here is actually a 0. So note that even though it says minus 3, okay, then you're going to actually have a positive 3 right there for your vertex, because it's going to shift the graph right 3 units in particular. So it does turn out that the vertex has coordinates 3, 0, and so this right here is going to be the vertex of our parabola. Now, the coefficient in front of that parentheses right there is really just a number 1, which doesn't really change anything in terms of stretching or compressing the graph. So what we're going to see then is the same sort of pattern that we saw with the parent function of the parabola, which we graphed back here, in terms of if I go over 1 unit, I'm going to go up 1 unit because 1 squared is 1, and then if I go over 2 units, we went up 4 because 2 squared is 4, and then over 3 units, we ended up going up 9, because 3 squared is 9, etc. And then it just gets mirrored on the other side. So that's exactly what we're going to do with this graph right here, now that we've got the starting point. So I'm just going to go over 1 and up 1, and then over 2 from the vertex and up 4, and then if I go over 3 and up 9, we get that, and then you just need to mirror that on the other side, since a parabola is always going to be symmetric like that, and then you can connect it all together, put your arrows at both ends, and that ultimately graphs the parabola there, of course. Now, this axis of symmetry, of course, is going to be this line right here, which is, of course, going to go through 3. So, of course, that vertex x-coordinate is always going to correspond to your axis of symmetry. But keep in mind that an axis of symmetry is actually a line. So you can't just say 3. You actually have to write an entire equation for a vertical line, which for a line with an undefined slope like that, we'll define that as being the equation x equals the number that it crosses through in the x-axis, which in this case is equal to 3. And then the last thing that we want to be able to identify is the y-intercept for sure at this particular point in time. Now, if you look at the graph that we just made, it's very easy to see where the y-intercept is, because it's going to be at the ordered pair 0, 9. But that's something that you should be able to find without looking at the graph, because you know that a y-intercept always has a 0 for its x-coordinate, so you should be able to use the equation y equals x minus 3 quantity squared, but then you should be able to take that 0 and plug it in for x, and then by following PEMDAS, do inside the parentheses 0 minus 3 is negative 3, and then negative 3 squared is equal to 9, so then we get y equals 9 when x is 0, so therefore, of course, the y-intercept is going to be at the ordered pair 0, 9. If you can find x-intercepts that are nice integer coordinates for these graphs, it's nice to be able to give them, but we're going to see that sometimes we're not always going to have nice x-intercepts, and we need a little bit more tools in our toolkit to know what those exact x-intercepts are going to be when they're decimals and such. We're not quite there yet, so we're not going to put a huge focus on that aspect yet. But for this particular graph, we can definitely see, like, obviously the x-intercept is going to be just one particular point there at the coordinates 3, 0. So if you want to give x-intercepts, you can when they're nice integer coordinates. For right now, we know that that would be at the ordered pair 3, 0 there. For this next equation right here, this kind of has a little bit of horizontal translation and vertical translation. And those two things that I just pointed arrows to are going to be the first things that you're going to want to do. Is you're going to want to translate to find where your vertex is. And then once you have your vertex, then we can do any stretching, compressing, reflecting, because that's going to be happening with that multiplicative factor that we have right there. So just focusing on what we see right here, we have a +1 on the inside. So what that does mean is you're actually going to go to the left, and so you're going to denote your vertex as actually being at -1, so always the opposite kind of sign that you see in the parentheses. But then on the outside, you'll keep the sign the same, and it's really just going to be a downward shift of 4 units. So that's going to be where your vertex of the graph is going to be located at -1, -4. So I'm going to go ahead and put that on the graph right there for our vertex. Now, what's going to happen is, because it's multiplied by 2, that's going to be a vertical stretch to this particular parabola. So what that ultimately means then is, when you go over 1 unit from your vertex, normally you go up 1, and then when you go over 2 units, you would go up 4, and then when you go over 3 units, you count up 9 units, and that's normally what you would see. But when the graph is stretched by a factor of 2 in this case, then rather than going by 1, 4, 9, 16, 25, etc., then you're actually going to multiply those vertical distances by 2. So that means that 1 is actually going to turn into 2, and 4 turns into 8, and 9 into 18, 32, 50, etc. So what that does mean about these values right here is that actually, when I go over 1, I'm actually going to go up 2 instead, because that's double as far. And then rather than go up 4, I'm going to double that and go up 8 units instead. And then rather than go up 9, I'm going to go up 18 units, which would be somewhere up there. So then that right there is actually going to be that half of the graph. And then, of course, then you can just kind of copy or mirror that over on the other side, sort of like this. And then that right there stretches this parabola by a factor of 2. And you can see that it's a little bit kind of skinnier than normal. So finishing off some aspects of this graph in terms of the axis of symmetry, you can see that it's crossing through -1 right there, so you want to define that as the vertical line x equals -1. And then finally, for the y-intercept, you can see that on the graph right there, it's crossing through -2, so it will be at the ordered pair 0, -2. Now, that is something that you should be able to find from the equation as well, because you know that 0 is going to be your x-coordinate for any y-intercept. So if you did use the equation 2x plus 1 squared minus 4, where you substituted in a 0 for x, then if you follow PEMDAS, so first in the parentheses 0 plus 1, and then do the exponent, 1 squared is 1, and then you can multiply next to give you 2, and 2 minus 4 is -2. Then right there you can see that indeed -2 is going to be the y-coordinate for where the y-intercept is located at. And then with this next example right here, this is also in vertex form. You don't see parentheses, but you can kind of think of this equation as really being like -3, and then just treat it as x minus 0 squared, because if you just have an x minus 0 inside, right, x minus 0 just simplifies to x, so it's still just x squared, and then plus 8. So what that tells you then is these two numbers are the horizontal and vertical translation. The 0 means you're not actually going to move left or right, right? But this 8 that's outside, that's added, is going to be your vertical translation. So it does tell you you're going to move up 8. So ultimately, your vertex is, of course, going to be at 0, 8, because you're not going to shift left or right, but you are going to move up, in particular, 8 units. So then the last thing that you'll need to think about in terms of getting the graph of this parabola is this stretch or compression factor, which in this case it'll be a stretch since it's a 3, but also it's negative, which is going to make it go upside down. So what you want to think about then is that for a parabola, normally you're going to go 1, 4, 9, 16, 25, like up or down, that sort of a thing. But because it's a 3, you're going to multiply 1, 4, 9, 16, 25, those perfect squares, all by 3. So these numbers right here that are all triples of these square numbers are actually going to be the vertical distances that you want to move by. So what that means is then when I start at my vertex and I go over 1 unit, I actually want to vertically travel 3. But because we know this is negative, the parabola is going to go upside down, so I actually need to go down 3 units. And then next I would go over 2 and then count down 12. That's going to bring me all the way down to there. And then I have to go over 3 units and then count all the way down to 27. That's going to be way far down, so I think we'll just kind of leave it with these dots right there. since it won't really fit on the graph, that would be kind of good enough in terms of stretching that by a vertical factor of 3 and then also flipping that upside down. For the axis of symmetry for this, the axis of symmetry is that vertical line right there, which is x equals 0. And then in terms of a y-intercept for the graph, clearly actually the vertex is the same thing as the y-intercept because it's crossing through 8 there on the y-axis. So we do know that the y-intercept would be at 0, 8. And you should also be able to verify that directly from the equation there as well, because you should be able to plug in a 0 for x. And then if you then simplify that, you get negative 3 times 0 plus 8, which is just going to equal 8. So of course that's going to be where your y-intercept is located at. And then one last example of graphing here. So you'll of course want to pay attention to the horizontal and vertical translation. So plus 4 does mean you're going to go to the left 4. And then plus on the outside does mean up. And so you're going to have negative 4, 2 is going to be the location of where your vertex is at on the graph that corresponds to that point right there in particular. Now what will happen here is now we actually have an example where there's a compression going on right here, and also it's negative, so the parabola is going to face upside down. So instead of then going 1, 4, 9, 16, 25, 36, 49, 64, etc., because of this compression factor of 1/4, you want to go 1/4 as far as all of these numbers. So if you do go 1/4 of all of these numbers, 1/4 of 1 is 1/4, 1/4 of 4 is 1. 1/4 of 9 is 9/4, which is really like 2.25. And you get 4. This ends up being 6.25, 9, etc. So then starting from our vertex, if you do travel 1 unit over, you're only going to go down 1/4. Because that's how far we want to go. And then when you go over 2 units, you're only going to go down 1, because that's 1/4 as far as you normally would go. And then 2.25. So if I go over 3 units, I'm just going to go down 2.25, which would be about right there. And then when I go over 4 units, I'm going to go down just 4. And then when I go over 5 units, we're just going to go down 1, 2, 3, 4, 5, 6.25. If you go over 6 units, you can go down 9, which would land you about right there. So you kind of get the idea, and then you can, of course, just mirror that on the other side. And then we'll make the nice kind of bold parabola shape that we get out of this here. So you can see that definitely the parabola is actually wider than normal, or it's a little bit more flatter like a pancake because we're vertically compressing in on this particular graph. For the axis of symmetry, it's crossing through -4 on the x-axis, so the vertical line x equals -4 defines this axis of symmetry. And then you can also see in this particular graph that it has a very nice x-intercept there at -2. You should be able to find that based off of the equation, because we know that 0 is going to be the x-coordinate. So if you do plug in a 0 for x into the equation and you solve for the corresponding y, then in the parentheses you get 4, which squared is 16, and then you can take -1/4 of that, which is -4, and then add 2, and you do get a -2 for your corresponding y value. So then, of course, that is going to be the y-intercept of that particular graph.